In destructive testing techniques, one of the principles was a spark, arc or spark type sample, where you take basically a welder and you touch it to metal and you look at the light off of that metal. That's destructive because the metal arc destroys some of the metals, destroys some of the samples. Usually the sample has to be cut into a small enough piece to sit and fit into an instrument, and the instrument can be very complicated. One of my pictures back there on the videos that I post is a very sophisticated time of flight measurement machine for isotopic identification and ratio analysis. So unfortunately my sample was corrupted. My fault, my bad. So that type of sampling, arc or spark, AC arc, DC arc, the polarity of the DC arc even makes a difference in how the material that you want to visualize, you want to turn into the rainbow. So you hit it with a high energy laser and smack the surface ions, the surface elements off of the sample, and you look at them. And if that laser hits hard enough, it gets below the surface. So when you turn the laser on and begin collecting your sample data, you're going to do some noise reduction techniques to take the first impulse noise and just remove it, subtract it, or don't even bother to measure it in the sample. So after a short period of the laser hitting the material, then you take your sample. You open up your optics and take that snapshot of the elements over a very specific period of time. Time is a key component. It's in the denominator of almost every differential equation for the sciences, somehow. So this arc or spark, I mentioned AC or DC arcs or sparks. Okay, AC is a sine wave with a positive and negative waveform. So the ions, the flow of electrons on the sample surface, is in one direction or the other, or both directions in the case of an AC spark versus a DC spark. Now we can get into semantics of, not semantics, the physics of measurements, and play some long games in there. We'll give it 20 hours worth of coursework. So stay tuned. But those techniques you can kind of relate to. When you go ultrasonic force, ultrasonic is a type of ablation. Those ultrasonic waves can remove surface materials due to a lot of properties of the materials involved at the dentist's office instead of the old polish and grinder. But they end up doing the polish. Just had my teeth done, so another trauma. So that type of sample matters in the conversations. Most conversations aren't going to go to that. They're going to refer to this information and not to the procedures, the process, the machine necessarily. But they might reference it so you can go verify what information they're talking to. So those techniques have grown over time. When I was first introduced, that laser ablation didn't really exist, but in some of the most sophisticated, expensive labs on the planet. But it was there. It just wasn't, something that when you're going down that big hallway of doors and open one up, you might or might not have seen. Now, inside the measurement sciences, there's a thing called stochastic probabilities. That huge word, I keep using it. It sounds silly, but stochastic, the concept is you see a huge building and you go up to the door. The fact that you saw that building and can go to the door has some possibilities. If you don't live in that town, you would never seen the building to knock on the door, right? But you're a tourist and you saw the building and you go knock on the door and they let you in. But inside the door is a hallway of more doors. So which door you choose is called a stochastic possibility. It's game theory, actually. It's the study of the possibility that you'll open door number 7 instead of door number 15. So if 7 fascinated you so much you went through, you would never see 15, yet 15 exists. It was possible for you at one point in the journey. That's stochastic. It's a very large part of knowing how good your measurements are, knowing what your measurements mean, and being able to bring it back into conversation. It is the basis, the fundamentals of whatever instrument measurement you're using, down to the teacup, the measurement cups in your drawer, in your kitchen drawer. So, interesting stuff people use to make the soap we use better, to make things more profitable. And sometimes inherent with that is better. Usually, that's what we've found. Maybe best idea stuff. Anyway, what was I talking about?